So this is the next problem. A capacitor is charged by a battery. The battery is removed and another identical uncharged capacitor is connected in parallel. The total electrostatic energy of resulting system has to be calculated. So this is the problem we need to solve. Let's solve it now. So let the capacitance of each capacitor be C. Initially, the first capacitor is charged by the battery to voltage V. So the charge is, let me write it as Q is equal to CV, right? Q is equal to CV. Next, the battery is removed. Before that, the electrostatic energy also we can write UI. Let it be UI is equal to half CV square. Of CV square. So we have Q and UI, right? Then the battery is removed. So total charge of the isolated system is conserved. So when an identical uncharged capacitor C is connected in parallel, now the total capacitance becomes C equivalent will be equal to C plus C, which is 2C. So now C equivalent will be C plus another C, which is 2C, right? Now the charge redistributes, but total charge remains Q. So the final voltage across both, that is now parallel capacitors, will be VF will be Q by C equivalent. I can write as VF is equal to Q by C equivalent, which is Q is CB, C equivalent is 2C. So C and C will get cancelled. So it is going to be B by 2. Okay. So this is what we get. So similarly, the final energy stored in the capacitors, right? The final energy stored in the capacitor, let me just write it as UF. I will just put it here. So the final energy stored in the combined capacitor is, let me call it as UF, which is half CQ into VF square. So already we have the UF. So let me write it as UF is equal to half. I have just substitute and show C equivalent into VF square. Which is C equivalent, already we got it as 2 times C into VF. Here we have got VF, right? So V by 2 the whole square. Is it not? So now let's simplify this. It will be half into 2C into V by 2 whole square will be V squared by 4. So this 2 will get cancelled. So what we get? C B squared by 4. We can also write this as 1 by 2 times another 1 by 2 CB square, right? Already this half CB square is nothing but UI. Therefore, half into UI. So now UF is given by UI times by 2. So this is what we found now. That is the total electrostatic energy decreases by a factor of 2. Meaning is it becomes half. Okay, so the this missing half of the initial energy is dissipated as heat or radiated when the capacitors are connected. Therefore, the answer for this question is subdivision A decreases by a factor of 2. Okay.